Hello, good people of geometry. Well, welcome to 5.2. I hope 5.1 went well for you. So now we're going to shift gears. We're going to take the idea of ratio and proportions, and now we're going to look at polygons. And when we say similar, we mean something very, very specific, okay? Similar has got a very distinct meaning in geometry, okay? If we say two things are similar, we're saying quite a few things about them, okay? We can't just say, oh, they're similar. Well, not necessarily, okay? Because in order to be similar, you have to follow into a couple different categories. So let's look and see what makes things similar, okay? So now you have to be very, very specific when you say two things are similar. And when you say two things are similar, corresponding angles are congruent, corresponding sides are proportional. Okay, so if you notice, angle A is congruent to angle W, angle B congruent to angle X, angle C congruent to angle Y, and angle D is congruent to angle Z. Okay, all these pairs, the corresponding angles are congruent. So now the sides need to be in proportion. So if you look over here, 5 matches up to 15. Okay, so we have 5 over 15. 4 matches up to 12, so we look at 4 over 12. 7 over 21. And 6 over 18. Okay, so now if we simplify all of these, they all simplify to 1/3. So those are all equal. Okay, so both of these things have to be true in order for two polygons to be similar. Okay, that's what has to happen. Sides in proportion, corresponding angles congruent. So for here, we'll do two things. Okay, we're looking at, and notice one thing. This is the symbol for similar. It is just the tilde, just kind of a little squiggly line that matches up. So if we look, I will say angle F is congruent to angle J. Angle G is congruent to angle K. And angle H is congruent to angle L. Okay, and remember, these still correspond up here in my what's now called similarity statement. That tells me kind of how things match up. Okay, and then for sides, so if I say FH, okay, that will match up to JL. That's got to be equal to FG. That's got to be over JK. Then if I match up GH, that's got to match up to KL. All those three need to be in proportion with each other. Okay, so here's my angles that are congruent, and here's my sides that are in proportion. And that's what tells me that these two things are similar. Okay, so now when we look at a scale factor, okay, please notice you're going from ABC to XYZ. So you're going from a bigger polygon to a smaller polygon. And when that's the case, my scale factor needs to be smaller than 1. Okay, and my scale factor needs to be smaller than 1. So how do I do that? Well, my scale factor here, I look at the sides that match up. Okay, so AB matches up to XY. Okay, so here I would put XY over AB. So it'd be 3 over 6. So my scale factor would be 1/2. Okay, it needs to be smaller than 1 because I'm going from bigger shape to smaller shape. If I flipped it around, then it should be bigger than 1. Okay? All right. So you're given a picture that is 4 inches by 6 inches, and you want to resize it so it's 8 by 10. Would your picture remain in proportion? So is 4 by 8... Okay, because 4 by 6, and you're trying to go to 8 by 10. Is 4 by 8 the same thing as 6 by 10? No, it's not. So you would have to say, no, it's not going to remain in proportion. So all I did was compare. This becomes 1/2. This does not equal 1/2, so it doesn't work. Okay, so those two would have to match up if it was going to work. Okay, so now let's look. Are these triangles similar? If so, write the similarity statement. Okay, so now, all right, so now here let's look and see. So, okay, so we have N matches up to R. Okay, so then we have Q matching up to S. Okay, so those two are congruent just based on their markings. I'm talking about the angles now. So by default, P is going to be congruent to T. Okay, just because they're triangles, they have to add up to 180. So if N is congruent to R, Q is congruent to S, then P is congruent to T. That works. Okay, those three match up. So now I have to consider, okay, does 9.2 over 11.5, is that equal to 10 over 12.5? Is that equal to 12 over 15? Okay, are those things equal to each other? So if we look at, that becomes 4/5. 10 divided by 12.5. That also becomes 4/5. So 9.2 divided by 11.5. That also becomes 4/5. So yeah, those are all equal. Those are all equal. So my similarity statement would look something like this. Triangle, and I'll just say NQP is similar to triangle RST. Okay, because that's how they match up. All right, so that'll be my similarity statement. Okay, so in the diagram ACDF, VWYZ, figure out the value of X and Y. So now they tell us flat out, hey, these two are similar. These two are similar. So now it's going to be a matter of what matches up to what. Okay, so FD here, DF, matches up to YZ. Okay, so I have X over 10. Okay, so then I've got, let's see, CD. So CD matches up to WY. Okay, so that'll be like 9 over 6. And that's important. That's what I want to use. Okay, so I have 9 over 6 here. So using cross products, X will equal 1, 5. So X should equal 15. X should equal 15. And then for Y, you know, you have 3y minus 1, and that matches up to 12. Okay, this matches up to this over here. All right, AF matches up to VZ. But then that equals, again, 9 over 6. So 6 times 3y minus 1 equals 9 times 12. You know, 9 times 12 is 108. 18y minus 6. And away we go. So now it's just a matter of some algebra. And for that I get, see, 3y minus 1 over 12, 6 over 9. No, wait, I made a mistake. Hold on, back up, I made a mistake. This should not be 9 over 6, it should be 6 over 9. Okay, because these should be from the same triangle. So this should be 6 over 9. My mistake. So that is incorrect. So a shortcut, this becomes 27y minus 9. 6 times 12, much more manageable, 72. So 27y equals 81. So y will equal 3. Much more manageable there. All right. So now, all right, so now let's look. If 2, so this is just kind of an extension of the previous idea, so that if the polygons are similar, you know, my sides match up and they have a scale factor there. Now I'm just taking it one step further and saying my perimeters are going to follow that same scale factor that the sides followed, okay? So it's basically the sum of the sides is going to follow the same scale factor that all the individual sides match up, okay? So let's look at this. So as I look at this, this is 8, this is 8, this is 4, this is 4. So this one would be 3. Okay, so 3 matches up to 4. Okay, so my scale factor should be 3 over 4. Again, I'm going big to small. So my perimeter of this would be, let's see, 8 plus 8 plus 4 plus 4 plus 6. So let's see, 10, 12, and 8 is 30. Okay, so I'm going to have 30 over x equals 3 over 4. Okay, that's going to follow, or I'm sorry, this should be 4 over 3. Okay, because this is my bigger shape and it's going to be smaller. So I should have 4x equals 90. So how do I know that? Well, I know I'm going from bigger to smaller. Okay, but when I set up my proportion, I need to adjust. Okay, this was from the bigger shape. So this needs to come from the bigger shape. Okay, that's how I solve that. So I divide, let's see what I get. So x should equal, let's see, so that's going to be 2, 2.5. So 90 divided by 4, yeah. So this perimeter is just going to be 22.5. Okay, and again, locking that up, making sure that they're both, that the both things from the same shape are in the same location is key there. Okay. So again, we find the scale factor. Okay, so this time you're going small to big. Okay, so this is 7, this is 7, this is 4, this is 4. So my scale factor will be 7 over 4. Okay, that'll be my scale factor. So now I need to use that to kind of help me figure out some of these sides. So if I have 7 over 4, then that means I'll call this x. Okay, so I'll have x over 6 equals 7 over 4. Okay, again, these two are from the big shape, these two are from the small shape. So 4x equals 42. Okay, so x is going to equal 10.5. So this will be 10.5. Curious? Okay, curious. All right, 42 divided by 4 should still be 10.5. Yes, interesting. So this is 10.5. So now let's work backwards and figure out these sides. Call those y. Okay, so I have, let's see, so that's going to be y over 10.5, and then that will equal 4 over 7. So 7y equals 42. Little division, y equals 6. So these all end up being 6. So my perimeter just becomes the sum of all these. So 8, 12, or 6, 12, 18 plus 8 should be 26. This one's going to be 10.5, 10.5, 10.5, so 31.5 plus 14. And I'm just adding up my sides here. So that should be 45.5. There's my answer. Now this was a little muddled. This was a little muddled. I took that, but it all stemmed from this idea of 4 and 7 matching up. And that's kind of how I used it kind of a couple of different ways to help me fill in my sides. That's what I'm doing. That's what I'm doing. Okay, so start playing around with this idea and come ask me questions. Thank you.